today's focus will be on coal. Coal is also considered a fossil fuel along with oil and natural gas. Coal is an organic sedimentary rock which formed from plant material such as moss, ferns, trees, things like that, a long, long time ago in a swamp-like conditions. Okay, so coal was made from plants that died and started to decompose in swamp areas, and that's how and where we got coal. Organic means that it is made out of hydrogen, carbon, and oxygen. You need all of those elements in order for you to have coal. Okay? And it's just a relationship between the different types of coal actually just have a different amounts of carbon to hydrogen to oxygen ratio. Okay? So let's review a little bit on fossil fuels. Remember, fossil fuel is non-renewable, meaning that it will not be renewed within our lifetime. That formed a long time ago from plants or animals. For coal, you are talking about just plants. That's not how you spell coal. C-O-A-L. Okay? It's kind of cool to talk about with all these fossil fuels is that it actually started with photosynthesis. So when you think about photosynthesis, what plants do is they take in that sunlight and they convert carbon dioxide and water into energy. And they create these compounds that have carbon, hydrogen, and oxygen in it. And so what happens is that the process of burning these fossil fuels is what we're doing actually the exact opposite of photosynthesis. So we're using this carbon, hydrogen, oxygen product that was made, and we are converting it back into carbon dioxide and water while releasing that energy. Okay, so let's talk about the formation of coal. So first off, coal was formed in swamps a long time ago with organic matter from plants. So key words on that is that coal is from plants and was made in swamps. Okay, as I talked about in the previous slide, organic materials have carbon, oxygen, and hydrogen. And the reason why this makes sense is because, once again, it all originated from the process of photosynthesis, whose primary elements are carbon, oxygen, and hydrogen. Okay, so then you have this plant, okay, that dies, right, and it's buried. And so this hydrogen, oxygen, and carbon are buried along with it because that's what the plant is made out of. So I'm going to kind of just write, I guess, a formula down. So we have this process. This is the basic process of, let's say, photosynthesis, right? And so you make some sort of mushed carbon, hydrogen, and oxygen combination compound, okay? And so when we're burning a fossil fuel, what we're actually doing is going from this guy and we're going back to this guy, okay? But what happens with this when we're developing coal is they did produce this guy. Now, under a lot of pressure, what can happen is that the water gets squished out. So some of this hydrogen and oxygen will actually be squished out. So you will end up by losing water. So you lose some water by being squished out. Think of it like a sponge, right? So more and more pressure, the water that was in a sponge would be squished out. You have a higher percentage of carbon. Okay? So you start with, the plant starts with water and carbon dioxide, and it converts it into this sort of CHO molecule. Then it dies, it goes under a lot of pressure. You lose some of that water by it being squished out, and now you're ending up with a higher percentage of carbon. Okay? Coal is found in beds called seams, and these seams are between 0.5 and 3 meters tall. Remember, 3 meters is about 9 feet. Okay? It's actually probably closer to 10 feet, but we've got about 9 to 10 feet. And then some seams, meaning some of these little pockets within the ground, are actually 30 meters tall, which would be between 90 and 100 feet. Okay. There are two main coal producing periods. Remember, what did we need to produce coal? We need swamps and we need lots of vegetation, meaning plants. And the two periods in the past that we have created this coal was the Carboniferous period and the Permian period. And what were the conditions? Once again, there was a lot of vegetation during these two periods, and it was all by the equator, so it was extremely warm, and by shallow seas, which means kind of like swamps. Okay, so it's very shallow, so that the plants died and then they were buried really fast and then they were able to be produced into coal. All right, so there are different types of coals. Not every type of coal is created equally, right? Some have been squished longer and more, so more water has been released. The higher the percentage of carbon, the more energy it has, okay? So let me repeat. The more carbon it has as far as percentage-wise, the more energy it has, which means that it is a direct relationship. So the amount of energy is directly related to the percentage of carbon. So as things have gotten squished more and more, you get better carbon, or you get better coal because you have more carbon percentage-wise. Okay, so the very first type of coal that you produce is something called peat. Okay, and this has a very high percentage of water. What happens next is that you squish some of that water through compaction and stuff like that, and you drive off a lot of that water and some methane and some other stuff, but you're basically becoming more and more carbon. And so by the time you are turned into what the second type of coal is, which is lignite, Lignite, you have 40% carbon, okay? This is not very efficient. You don't want to burn lignite because it's got too much water. It's not enough carbon percentage. So this is not the ideal. Now, can you burn it? Yes, you can also burn peat. They use a lot of peat where they're what we call bogs, and those were found in Scotland and Ireland. They have a lot of peat, and what these people would do is they'd pick up this peat, they'd dig it out, and then they'd burn it in their house. But it leaves a lot of ash, and it doesn't produce actually a lot of energy for how much you would have to use. So it goes peat, then it forms into lignite. After lignite, you squish it a little bit more, and you get bituminous, okay? Bituminous coal. Bituminous coal is 85% carbon. So remember, lignite is 40% carbon, bituminous is 85% carbon. How did we get that? Remember, we squished out more and more water and kind of other random stuff, but it's primarily water. This still produces a lot of smoke because you still have a lot of water, you still have a lot of impurities in it, but this is much better to use for bituminous than it would be for lignite. And then the last one is anthracite. Okay, anthracite is like the best type of coal you could ever have. Okay, what happened is it got squished more, and you're talking for anthracite, it is between 90 and 95% of carbon. This guy will burn very cleanly. You will not have a lot of smoke, and it will produce a lot of energy for its size. Once again, how do you do that? You squish out that water. All right, so here's the stages of coal, just kind of looking at it. So we have peat. So peat is very, it's more on the surface because it hasn't been squished a lot. That's why you can dig it out in like Ireland and Scotland. But you can burn it. It does have some carbon in it, so you can burn it and produce some energy. It's just not very good. Then you get lignite. Okay, so it's more compressed peat. You lose some water. Remember, this is about 40% carbon. Then you get to bituminous, which is 85% carbon. Still a lot of smoke and things like that. And then the last one is anthracite, which is 90 to 95% carbon. So this is your best of the best. Now, how do I remember the order? It's very easy. You go opposite of ABC. So it starts with P, L, B, A. So it goes the opposite of alphabetical order. So it goes P, then L, then B, then A. And it's not too hard. We're not going to make you memorize necessarily all of these off the top of your head. You're going to have to be able to put them in order. And so as long as you remember that they are in alphabetical order, pretty easy to put these guys in order of formation. All right, so let's label which type of coal is formed in each picture. The first one is going to be peat. Then comes, you've got your P, now you're going to go with L, which is lignite. Then you've got your bituminous, and finally you have your anthracite. Remember, anthracite is your best, peat is not so bueno. So rating from coal from most energy to least energy. So the one with the greatest amount of energy will have the least amount of water. Why? Because it's got the most carbon percentage. And when you're talking about burning and getting energy, you want the most carbon percentage. So which one has the greatest amount of energy? That would be anthracite. Then the second would be bituminous. And notice as we're going kind of backwards, because we're going from greatest to least amount of energy, you're adding more and more water according to these images. Okay, and then we end with peat. All right, so where is coal found? Well, let's talk about the United States. Coal reserves. What a reserve is if I buried it underneath the ground, or if I dug underneath the ground, how much coal do I have access to? And so if you look at our top states, we've got Montana, Illinois, Wyoming, West Virginia, and Kentucky. So these states have the most potential with the coal. Okay, so underneath the ground, these are approximate how many we've got. If you notice, Illinois is really a high coal area. We have a lot of reserves. The problem with Illinois is that it's actually very dirty coal. So when we're talking about a high percentage of carbon, we actually have quite a bit of sulfur instead added into it, which makes it dirty. Okay, then we've got some coal production. So what does coal production mean? Coal production is the act of actually taking it out of the ground. So even though Illinois was number two on the list, Illinois is actually number 5 on producing coal, so digging it out. So even though we have a lot, we're not the number 1 in digging it out. And so you've got Wyoming, West Virginia, Kentucky, Pennsylvania. So if you look at coal, where is most coal dug? It's actually found out west or dug out. It's done out west in Wyoming. All right, so let's circle the top 5 with coal reserves. Remember, with coal reserves, you're talking about Montana, you're talking about Illinois, you are talking about, that's not Illinois, by the way, that is Kentucky. You are talking about Wyoming, and that is West Virginia, and then you've got Illinois. So those are the reserves. Remember that the reserves are the ones that actually have it buried underneath it. So you're kind of looking at the blue for this image. And then we're going to try to box out the ones with coal production, so meaning who takes out the most coal. So remember, these guys would be Wyoming, West Virginia, Kentucky, Pennsylvania, and Illinois. So notice that there's some overlap, but Montana has the most reserves, but it's actually not, it's not even mentioned in the top 5 for coal producing places. All right, so who uses coal the most? Well, China is the biggest coal producer, meaning user, or consumer, followed by the United States. Now, if we look at this graph, the United States is in blue and China is in orange. So, but if you, and then the purple is the rest of the world. So if we're just looking at the top 2 countries of comparing US to China, what do you notice about actually the United States' usage due to coal? I hope what you notice is that it basically has remained constant. Relatively constant, right? As far as usage. But if you look at instead, if you focus on China, what do you notice about that amount? You notice that China is using more and more. So it's increasing its usage, whereas the United States has had a lot of usage, but now it's kind of like leveled off and we're not doing it anymore. All right, well, this graph our chart is extremely difficult to understand, so I'm going to take it slowly and try to explain it. So these are our sources of energy, okay? These on the left are our sources of energy, and these guys on the right are where we use that energy, okay? So I'm going to focus on, I'll talk about petroleum first, okay? So that's oil, right? So out of the petroleum, so these guys would add up to 100%. Out of the petroleum, so out of a barrel, let's say, of oil, 72% would go towards transportation. 23% of that barrel of oil would go towards industry, 4% would go towards residences, and only 1% would go towards creating some sort of electrical power. Okay, so that's on the percent of the source. So this is like for the barrel of oil. Now, if you look at transportation, so on this side, this is the percent of sectors. So out of transportation, 92% of it comes from petroleum. 3% of transportation comes from natural gas. And then 5% comes from some sort of renewable. All right. So let's answer the questions about industry. But we're focused on, obviously, in coal for this unit. So where does industry, what percentage of industry gets its energy from coal. So that means we're going to be on this side of the graph, and we are looking for coal, which is this dark blue one, and we're looking at what its percentage would be, which would be, so 7% of industry gets its energy from coal. How about electric power? So out of all of our electric power that we use, what percentage do we use from coal? Well, so we're on electric power. We're going to go back. Coal is that dark blue, so that would be 37%. And if you look at commercial use, what percentage comes from coal? So once again, we're on this side, and we get 1% of commercial use is from coal. All right, so once again, we're going to repeat kind of what we did over the nuclear unit. Is we have this coal, we know that it's used in electrical generation. So how does that work? Okay, well, let's talk about it. So coal is burned, okay, produces heat. That heat is then heats up water directly. So you burn the coal, you heat up water. That water then turns into steam. The steam turns the turbine spins the generator produces electricity, and then you have the electricity then transmitted out to the people's homes and stuff like that. So what do you notice that I'm hoping that you notice that it's very, very similar, if not almost identical, to nuclear power plants. The only difference is where did our source of energy come from? And in this one, we burned coal, whereas in nuclear, what we do is we have a nuclear reaction. There's no burning going on. Okay, but both, the whole point is to produce this heat. All right, so let's label the energy transfers that occur inside a coal burning power plant. So once again, this should look very similar to you because it's almost identical to your nuclear power plants. All right, so the first one that we're going to talk about is this guy. So this goes from one type of energy source to another, and this would be chemical. We are burning it, so we are breaking those bonds. We're breaking that chemical bond, and we are turning it into thermal, okay, because we are turning it into heat. Then we've got this one right here, and this is going to be heat from the fire. It's going to then go heat to the water. Okay, so it's heat, so it's thermal to thermal is really what it is, or heat to heat, thermal to thermal. All right, then we've got turbines. This is actually, we've turned the water into steam. Steam has the ability to move, so we've got motion of the steam, and its job is to turn those turbines, so it's motion to motion. The next one is the generator. So once again, we've got this turbine. It's turning a shaft in the generator. So we are going from motion of that shaft being turned to electrical, because the whole point of the generator, electrical, is to produce electricity. So we're going from motion to electrical. All right, hopefully you have a basic understanding of coal, and have a great day.